I was telling you that your definition of miscible liquids, you are supposed to give the example. And the example of miscible liquids was ethanol and water. Immiscible liquids, we also saw them, which was part of the question. For them, they do not mix together in any proportions, and they form separate layers. And an example was supposed to be oil and water. We have paraffin and water. We have petrol and water. All those are immiscible liquids. So you drew the diagram very well. That was good. But after the diagram, since the question had said describe how, you draw the diagram and you write some short notes talking about your diagram. You say, place the mixture of ethanol and water in a distillation flask as arranged above. Heat the mixture until when it begins to boil. Ethanol having a lower boiling point will come out first, and it will be collected as a distillate. So that is what I wanted, and you did it well. Applications of fractional distillation, we saw them the other time. Now, the diagram here, you drew it, but you did not talk about it. When the question says, describe how immiscible liquids are separated, you draw the diagram and you talk about it. Say that oil settles on top of water because it has a lower density than water. The reason why these two liquids are separated by using a separating funnel is because they have different densities. Now, today, let us look at how we can separate. We are now looking at separation of volatile solids from non-volatile liquids. Volatile solids from non-volatile solids, we mean solids which do not easily melt, or which are not easily affected by heat. Those are non-volatile solids. Then volatile solids, these are solids which are easily affected by heat. When you heat, we are saying solids that can sublime, they are the ones we are calling volatile solids. Solids that can sublime, we call them volatile solids. They can be separated from solids that cannot sublime by sublimation. So the method that is used to separate two solids, when one of the solids can sublime and the other solid cannot sublime, the method we use to separate is sublimation. If I were to ask you examples of solids that can sublime, you remember we looked at them in term 1 when we were looking about at matter. We saw iodine sublimes, iron 3 chloride sublimes, ammonium chloride sublimes. So when you are separating any mixture and any of those solids is there, separate them by using sublimation. What is sublimation? Sublimation definition, it is the direct change of state of a substance from solid to gas and from gas to solid without going through the liquid state. That is the definition of sublimation. It is the change of state from solid to gas and from gas to solid without passing through the liquid state. Sublimation method can be used to separate volatile solids. We have said volatile solids, those are solids that can easily sublime. And examples, we have iodine solids from its solution of water. Volatile solids mixed with non-volatile solids, e.g. iodine and common salt. Remember, iodine is one example of solids which sublime. Iodine, iron 3 chloride, ammonium chloride, those substances sublime. So wherever they are, for example, if you have a mixture of iodine and sand, sand does not sublime, but iodine does. So when you heat that mixture, iodine will just sublime and you will correct it. So examples of substances that can sublime are, we have iodine, we have ammonium chloride, we have anhydrous iron 3 chloride, and anhydrous aluminium chloride, and benzoic acid. But the common ones that you must know are these first three. Please, these first three, have them in your head. Iodine, ammonium chloride, anhydrous iron 3 chloride, and aluminium chloride. Those are some examples of the examples of substances that can sublime. Meaning, if they are mixed with other solids, they can be separated by sublimation. Separation of iodine and common salt. Common salt, we mean this salt which is sodium chloride. And we have a diagram here, as you can see. So this is a mixture of iodine. This is a mixture of iodine and common salt. So I invert a funnel on top of the iodine. And when I heat this mixture of iodine and common salt, iodine will evaporate off. And when it reaches the top of the funnel, it is collected. It is collected because sublimation, it is change from solid to gas. So iodine is collected here as a gas, but when it reaches the part which is cooler, it will again solidify. It will again solidify and change to solid, and it is collected there. But sand which does not sublime remains in the beaker. So iodine will be collected on top here. Sorry about that. I'm having some flu here. Procedure, like we have said, a mixture of equal amounts of iodine and common salt. Common salt, we have been saying it is sodium chloride, is placed in a beaker with a glass filter inverted on top. This is the glass filter that is inverted on top, over its top. Then the beaker is heated. When the beaker is heated, I repeat, iodine sublimes off and it will leave the salt down because iodine has a characteristic of sublimation. Observation, when heated, iodine solids sublime, forming a purple vapor that settles inside the filter funnel, forming gray solids of iodine. So iodine will sublime off and it will leave the salt behind. White salt is left in the Pyrex beaker, and in so doing, you have separated a mixture of iodine and sand. Now, that is what you do for every solid that sublimes when it is mixed with another solid that it does not sublime. It can be ammonium chloride and sand. When you heat, ammonium chloride will sublime. It can be iron 3 chloride and sand. When you heat, iron 3 chloride will sublime and the sand will be left behind. So the important part of this chemistry is sublimation. It's all about sublimation. Let's look at another method of separating solid mixtures. And that method is by using a magnet. Separation of magnetic substances from non-magnetic substances. You may have two solids where one of the solids is attracted by the magnet and the other solid is not attracted by the magnet. Those two solids can be separated successfully by using a magnet, such that the magnet attracts the magnetic material and leaves behind the non-magnetic material. So magnetic substances are attracted to a magnet, while non-magnetic substances are not. Therefore, they can be separated by magnetic method. Magnetic separation, this method can be separated from ferromagnetic substances like iron filings from non-magnetic substances like sulfur. So if you have a mixture of iron and sulfur, for example, you know iron is a metal. So iron, like an iron nail. So when I say iron filings, I mean those filings that are made of iron. So iron filings are attracted by magnet and sulfur is not. So if you have a mixture of iron and sulfur, that mixture should be separated by a magnet, by using a magnet, such that the magnet attracts the iron filings and leaves the sulfur behind. So procedure, if you have a mixture of iron filings and sulfur, the procedure is here. We are saying place a mixture of iron filings and sulfur on a watch glass. This is our watch glass as shown. Then pass a bar magnet over the mixture. The iron filings will be attracted by the bar magnet, while sulfur will be left behind on the watch glass. And that is what happens. Separation of different solids. Solids, we mean substances that dissolve in water. If you have two substances and they are mixed together and they all dissolve in water, but they have different solubilities, those substances should be separated by fractional crystallization. So we are saying two or more solutes can dissolve in a particular solvent, and solvent we mean a substance that dissolves the solutes. For example, if I have a mixture, if I get 1 spoon of sugar and I put it in a cup of water, water is a solvent and sugar is a solute. Two or more solutes that can dissolve in a particular solvent are separated from each other on the basis of their difference in solubilities. E.g., a mixture of potassium chlorate and potassium chloride can be separated from the solution by fractional crystallization. So what is fractional crystallization? This is the method of separating two or more solutes by crystallization using their differences in solubilities. So the criteria or the reason for separating solutes, two soluble substances by fractional crystallization is by using their difference in solubilities. That is, one substance may be more soluble than the other. We use fractional crystallization. So crystallization alone is the process of forming crystals by evaporating a saturated solution. That is crystallization. So in fractional crystallization, a mixture of two solutes, e.g. salts, with different solubilities is dissolved in a minimum amount of hot water to make a saturated solution. That's what a saturated solution, you make it by using minimum amount. So a saturated solution is like a solution which is concentrated, which cannot dissolve any more solute. It has enough solute. that can dissolve. So the solution is allowed to cool, and as it cools, it forms crystals. The crystals are filtered. It is then filtered, and more soluble salts remain in the filtrate. So the salt that is more soluble remains in the filtrate, and the one that is less soluble remains in the filter paper. That is the method of fractional crystallization. So fractional crystallization, it is the method of separating two soluble substances or two soluble solutes by using their difference in solubility. When they have different solubilities, those substances can be separated by fractional crystallization. So solvent extraction, we shall look at it in A level, but no, when substances have different solubilities, they can be separated by fractional crystallization. Now, Rudingo, your network has been on